There's this thing going around called Project Skydrop that is basically a treasure hunt where there's a map online and there's a circle on the map and it shrinks every single day until eventually it shows you where this multi-thousand-dollar piece of gold is, and you can get more hints by like paying 20 bucks or whatever. And I was like, oh, they're listing out the amount of times that the circle's going to shrink, and they're listing out how big the circle's going to be at each shrinkage. So there must be some mathematical way to solve for where that treasure is going to be, right? I mean, if you've got a circle that's 10 miles in diameter, and then the next day you've got one that's 5 miles in diameter, and it keeps on shrinking down, wouldn't you be able to figure out where exactly it's going to converge to, or at least narrow it down to like 12 options or something? And so I spun up a little map and I started plotting circles on it, and eventually I realized that actually no, you can literally converge to any point in the circle, and I can mathematically prove it. Here's how. So if I have a circle right here, and I'm going to be choosing a secret point within the circle, say it's the point right there, and I want to progressively create circles smaller and smaller, leading people to that point eventually, well, I could choose any arbitrary point within this circle as the secret point, right? And my incorrect theory was that there were only a handful of points that you could converge to within the circle doing something like that. That is not right. So let's say that I choose this point. How would you cut the circle in half and then converge to it? Well, you draw a circle like this. It's like half the diameter. And then you draw a circle like this the next day that's like half the diameter, and then like this, and then eventually you get down to your point. And you know, it's kind of a crappy drawing, but it illustrates what I'm talking about, because you could also just do it on the other side, or you could do it right here. You could converge to this one, or if you wanted to, you could choose this point right here, and you could draw a circle right there, and then 5 days later, you know, you could have a circle about this size, and then you could get down to there. And the way you could formally write that is like this. For every single point X within a circle C of diameter D, there exists another circle with diameter D2 such that X is within that circle C, and also D2 is less than D. So here's our circle C. That's really a terrible circle, but here's C, and it's got diameter D, and let's just choose an arbitrary point X right here. This right here states that there exists a circle D2, or a circle with diameter D2, with D2 being less than D, so there exists some circle. This circle wouldn't cut it, because while the diameter is less than D2, X is not in that new circle. But there is a circle that does it. There you go. So I guess the next step would be to prove that maybe if D2 is half of D, or you know, whatever rule they're using to generate these circles. But basically it's just a proof that, or I mean, this isn't really a formal proof, but this is a statement that kind of encapsulates the reasoning that you can't just say there's only a couple select points you could get to. You could really get to any point in the circle using this. And it's simple to see because it's kind of recursive, right? You start with one circle and you say, okay, can I draw a circle within the circle that captures any point? And the answer is yes. And then once you draw that circle, you can do the same thing. Can I draw a circle within the circle that captures any point? Say it's over here. Yes, you can. So that was an unfortunate thing to realize, but maybe there's another way to take a shortcut on that challenge. I'm still thinking about it.